Hello, here we go again. This is Math Vibes Tutoring. We're going to talk about factoring by groupings today. Several of you have requested this lesson just to kind of get your feet wet before you go back to class. You've already done factoring by GCF. So we're going to continue with this with factoring by grouping. There's so many different ways that we can factor, but this is a pretty cool way to factor. Okay? So let's do a few examples. And let's see here. All right, example 1. We have this polynomial, 12a cubed minus 9a squared plus 4a minus 3. Okay, when we are factoring by grouping, we are trying to separate this polynomial so that we can find a common binomial factor. So let me show you what I mean by that. Okay, I am going to separate this polynomial. I grouped the first two together and then I grouped the last two together. Okay, so what I'm going to do now is I'm going to take this first group and I'm going to pull out a GCF. So 12a cubed minus 9a squared. I can pull out a GCF, and that GCF would be 3a squared. That's going to be the GCF. Okay, that's the biggest term that goes both into 12a cubed and this negative 9a squared. Okay, so once I move and I pull out that 3a squared, what's left in that parentheses is 4a squared, 4a, not 4a squared, just 4a right there. Okay, then minus 3. Now, how did I know that? Simple, because if I multiply 3a squared by 4a, I get 12a cubed. And if I multiply 3a squared by negative 3, I get negative 9a squared. Okay? So it pulled out that GCF. Now, I need to pull out something from this second factor, the second term of factors right here, so that it's going to match this. Okay? So what can I pull out? Absolutely. It's going to be a 1. Okay? So my greatest common factor here is just going to be 1. And the reason why I just pulled out a 1 again is because I need to have common binomial factors. Okay? 1 times 4a, still 4a. 1 times negative 3, still negative 3. Okay? But what you notice here now is that you have common binomial factors. That 4a minus 3 is going to be a common binomial factor. So that is going to be one of our factors in our answer, 4a minus 3. Okay? The other factor that's going to be in our answer is whatever is left over. Okay? So right here, that 3a squared, and then that positive 1, that's going to be your next your factor. So this now is 3a squared plus 1. So this right here is your final answer of how to factor 12a cubed minus 9a squared plus 4a minus 3. Factors into 4a minus 3 times 3a plus 1. Okay, so that was one example. We're going to do another example. We, of course, can always go back and check behind ourselves because we can actually use our distributive property and multiply all of these terms out, and it'll give us the original polynomial. Okay, so let's do another one. Let's look at this one right here. So we have the polynomial 2p cubed plus 5p squared plus 6p plus 15. So if we're going to factor it by grouping, again, our goal is to find a common binomial factor. Okay, so let's group the first two terms together and let's group the last two terms together. Okay, so if I'm looking at just this first set of terms right here, okay, Can we find a greatest common factor between 2p cubed and 5p squared? What will be the greatest common factor? Great, that's right. That would be p squared, okay? Because p squared is a factor in 2p cubed and 5p squared, okay? So once we take out that p squared as your greatest common factor, we are left with 2p plus 5, okay? Again, p squared times 2p is 2p cubed. P squared times 5 is 5p squared. Okay? So what we need now is to take out a GCF on this one, the 6p plus 15, so that when we take it out, what's left in the parentheses matches this 2p plus 5 in order to have a common binomial factor. So let's think, what is going to be a greatest common factor between 6p and 15? Very good. That will be 3, a positive 3. And I always put that plus sign there so it's very clear that I am dealing with a positive 3. Okay? And so again, we know that this is going to be right because if I multiply 3 times 2p, I get 6p. And 3 times 5, I get 15. So you can see here that 2p plus 5 and 2p plus 5, those are common binomial factors. That's going to be one of your factors. So 2p plus 5, that's going to be a factor. And then again, whatever is left over is going to be your other factor. So p squared plus 3. Okay, so p squared plus 3. So these are your factors. Factoring by grouping. Okay, and again, how will we check it? We can multiply it back out and we'll get the original polynomial. Let's do one more. Okay, all right, so we have 3n cubed minus 4n squared plus 9n minus 12. So the same way that we've done every single time, let's group the first two and then group the second two. Okay, so looking at the first polynomial, this first set right here, this 3n cubed minus 4n squared, let's find the GCF. The GCF, you're absolutely right, is n squared. Okay, n squared. So let's figure out what will be left in our parentheses here once we remove that greatest common factor. Well, I know I'm going to be left with 3n. Okay? And 3n, and then I'm going to be left with minus 4. Okay? And again, I know that this is right because n squared times 3n is 3n cubed, and n squared times this negative 4 is negative 4n squared. Okay? So now, let's figure out what we need to do in order to take out a GCF of this one so that what's left over in the parentheses matches 3n minus 4. So our greatest common factor here would be, you're right, positive 3. Okay, and so what's left is 3n minus 4. Again, we know that that's right because 3 times 3n is 9n, and 3 times negative 4 is negative 12. So this is your common binomial factor. Notice that's your common binomial factor. Okay, so this right here is going to give us 3n minus 4. That's going to be one of our final factors. And then whatever's left over is going to be your other part of your factor. So n squared plus 3. N squared plus 3. And that is factoring by grouping. And again, you can always go back and check your answers because if I use a distributive property and multiply every factor, it will give me the original polynomial that I have. Okay, hopefully this helps you out. If you have any questions, hit me up in the comments. Be sure to subscribe. Until next time, bye-bye.